Okay, so to start out, guys, I wanted to finish talking about a couple things on that beer and blood alcohol example. So do you guys have the model written down from yesterday still? Can you feed it to me? What is our regression model that we had?
Y equals 0.01796 x minus 0.0127.
27? Thanks, guys. So that was the blood alcohol content and beer model that we had yesterday. If you still have it in your calculator, I think we're going to do just a couple other things that I left out. So the first one is, how can you, once you create a regression model, have your calculator populate that onto your scatter plot. So let's see. My data is still in my lists, it looks like. I think my scatter plot's still on. Yay. So I'm going to go zoom 9, and there's the scatter plot we had yesterday, right? So how can you populate that? Kinsey told us yesterday that you could just go to y equals and like type it in manually. That's of course an option, but that involves rounding. What if you want the best one on there? Or what if you just want to be slick? Then you go vars. Oh, first you need to calculate your regression model again, sorry. Stat, where do I go? Calculate a model. I want a linear regression model. Okay, now mine is loaded on the home screen of the calculator. So if it's loaded, you can go to y equals and hit vars. Where did we go last time? Statistics. And you can start looking around for regression model stuff. So there was like A's and B's, right? You see any A's and B's? No. Which one of those top menus do you think might have the thing we want in it? EQ. Oh, it does. It has the A's and the B's. If you remember what order they were, it'll pull them right off your home screen and put them in there for y equals. Or even better, what do you think option 1 says? Regression equation. So even if you have some other kind of equation, like a parabola or a logarithm or something like that, if it's loaded on the home screen right now, what's it going to do? It's going to grab it and put it into as much accuracy as it computed your model. If you're not sure, scroll backwards. Look at that. See? Can you see our line right there? Yeah? Let's hit graph. Does that look like the best fit line? Yeah, that's the one. That's the best. There you go. So if you're asked to make predictions, like for instance, you might have a question that says something like, predict the blood alcohol content of a person who drank 9 beers, then you'd say VAC hat of 9 equals what? You could plug it in there and do the math by hand, or you could do things the fast way, because that is now in Y1, right? So of course, we can all plug that in by hand. It's the easiest algebra thing ever. So quit, if you go vars, y vars, function, where did we just put our regression equation? Function 1. Plug in whatever you want. Uh-oh. Not like that. Like that. The person who drank 9 beers is going to blow a blood alcohol content, according to our model, of 0.18, 0.149, whatever its units are. I don't know what its units are. Alcohol units. If you want to make another prediction, hit second entry. A person who drank 20 beers has their blood that's like 34% alcohol. Yeah, that's probably going to lead to death depending on how fast that happens, right? It depends. But anyway, that's what our model is predicting. Let's go back to our model that we have right here. If you were asked, like I just did, to use the model to predict 9 beers, is that okay? I think so. Let's see where it falls on the plot. Here's how you use your calculator more. Go to second, calculate value 9. And that's another way to get your calculator to plug it in for you. There's the same number we just had a second ago, right? And it even shows where it's at on the model. You guys see it? It's blinking up here. So if I were asked on this problem to predict the blood alcohol level of someone who drank 20 beers, we got that ridiculous number. What would you say to the person who asked you to do that?
You're drunk.
Don't get distracted by the particularly
It's hard to
silly
say that.
context of this problem.
It's hard to say that because we don't really have the information for that.
Wonderful, Logan. In fact, that's a completely invalid prediction to be asked for. 20 is way down here, isn't it? It's way outside the range of data that we had that we used to make the model. In fact, the blood alcohol content might totally change for things down here or for things up here. It might just start leveling off because of some part of your anatomy. I don't know how blood and alcohol mix. I'm not an expert on that. I don't think any of us are. Maybe we could ask a doctor. I bet it would change. It might start curving, you know what I mean? And not be linear anymore. That's an invalid, and there's a certain word for it. Extrapolation. So let's write that down for our notes. Put it on your handout or whatever. If someone asks you to make a prediction in the y direction or the x direction, because they could, someone can come and ask us to make the other prediction too. They can say, a person who has a blood alcohol content of 0.1, about how many beers did they drink? We can plug 0.1 in here and do 2 steps of algebra and solve for x and get how many beers, right? You're going to be asked to do that as well. I'm not going to do it this time. But if someone ever asks you to make a prediction, where that value falls outside, especially far outside, the data used to build the model, just say no. But on the statistics test, you wouldn't want to just say no. You'd want to say, hey, this is an extrapolation, and then you want to say why it's an extrapolation, because I don't know what happens after this point. Things might change in the situation. Does that make sense to you guys? When you build a model, it's on the data you have. You can't use it to extend to data you don't have. That's clear, and that's what Logan said to begin with, so very good. This is called extrapolation, so write it on the board for anyone watching the video. A couple other things I wanted to do on this one so that you guys could finish that handout, the what's driving car prices, was interpret the slope and the y-intercept. That's pretty easy, but we didn't do it yesterday, so I thought I'd interpret the slope and the y-intercept just like the AP exam would want you to do, or any reasonable person. So let's erase all the way back up to here. There's our model. So the slope is that thing. So slope interpretation. In this case, I'd say 4. And don't stray far from this. If you stray far from the way things are phrased in statistics, the way I show you, you run the risk of saying something totally different. It's very easy to do that in this class. So for each, because slope is like rise over run, right? So let's just always assume the run is 1. Because you can always just put this number over 1, right? Unless it's like 2/3 or something. But you're never going to have that in this class. When you have regression models, there's always going to be some kind of decimal here. It might be 2.7, it might be 0. Whatever. You can always just put it over 1, right? So for each additional, or extra, or whatever, I like the word additional. Additional what? What's the X unit? It says it right there in your model. For each additional beer consumed or drank or whatever, an Ohio State student like these, it's a little extra, but that's the real good way to do it, would have an extra 0.01796 blood alcohol content score. Because I don't know what the units were. Did they say what the units were? I don't think they did. What?
It's easy to put 9.
Thanks. You guys get it? That's how you interpret slope. How you interpret y-intercept is even simpler than that. I don't think I'm going to write it down. You'd say for how many beers consumed? 0 beers consumed. We get a blood alcohol content of negative 0.01, and a lot of the time they'll ask you, does the y-intercept make sense? Sometimes it does, sometimes it doesn't. In this case, you have negative alcohol in your blood. I know, going to church a lot. Anyway, so you guys get the point, right? The last thing I wanted to do with this example was create the residuals. So you can create the residuals one at a time. Let's bring back the plot. Or you can do them all at the same time. Residuals, though, here's the formula you need to be familiar with. It's very, very easy. Residuals. A lot of the time the book calls them E for error. They don't call them R for residuals because why?
That's the regression.
That's the correlation.
Because R is the correlation coefficient. We've already used R. Right? So they call them E for error. Residuals are the error between the real things and the predicted things. So for instance, a residual for this point is going to be the predicted thing, the real thing. It's this distance. Don't make it harder than it is, because it's not. We're going to use residuals for a few things, like they're a good way to detect if a linear model is a good one in a sneaky situation. We'll talk about that next week. But basically, I'm going to take the real thing. So I'm going to say residuals are the real, or the actual thing, minus the predicted. And by the way, this concept of residuals is super important for like all science. It shows up in physics, it shows up in chemistry. It's percent error, basically, except for not using a percent. So real minus predicted for us is the y value, right? The thing that's that point minus, help me out with a symbol. What's the predicted thing?
Is Y.
Y with the little hat. There we go. So that's what a residual is. Can your calculator do these for you? Yes. I'm not going to show you how to do it the long way. I want you to practice for a little while before I ever show you the long way, because understanding how to do that is key. Let's create the residuals for this and look at the plot. If the residual plot, this is a preview of next week, if the residual plot looks random, your model is good to go. So let's create a residual plot. So I'm going to go back to my lists. And I think I'm going to get rid of all this junk in list 3 through 5. I'm going to put my residuals in list 3. You want to make sure your model's on the home screen still. I'm going to go check. I'm not sure, so I'm going to run it again. Okay, it's there. Yay. Okay, residuals. I'm just going to type that in my calculator. Where are the real things? The Y's?
List 2.
List 2? I just went and ran the model again to make sure it was there. Sometimes it gets deleted. Yeah, I ran the regression model again just to make sure it's accessible to me. Yeah. And Brandon, you said the real values, the Y's, are in which list? List 2 minus, what are we supposed to subtract? The predicted Y's. How do you get the predicted Y's? They're the ones that are on the line, right? Didn't we have our lines equation?
Oh, yeah.
Where was it?
Y bars.
Bars and then
List
Q.
Y1.
Yep. But I can't just press Y1 because that's just the function. I got to plug what into Y1 to obtain the predictions? I've got to plug each X value in. And that will create the list of residuals. Now, if you plot the residuals versus either X or Y, that's a good way to diagnose the appropriateness of your model. So far, we just had R. This is another way to diagnose the appropriateness of your model. Now, this one's real straightforward. Other problems we're going to see are much more subtle. So, let's go plot our residuals since we're at it today. So I'm going to go to stat plot. Scatter plot still, except I want to plot my x's versus my residuals, which are now in list 3. And I'm going to hit zoom 9. Uh-oh. Malfunction. Zoom 9 again. Now I have a random line over there now, right? This is not the original scatter plot. This is a plot of the x's versus the residual distance. Sometimes it's negative because sometimes they were where? Sometimes our points were below the line. So it makes sense that some of the residuals are negative. Does it look fairly randomly scattered to you guys? Or is there like a clear pattern in it? Maybe it's going a little bit like this, but that's a fairly random scatter. That's another way to say we did a good job creating our linear model. Residuals do all kinds of things for you. That's one of them. Okay? You guys now have everything you need to finish that for car prices handout. I'm going to put the key to that up later today. I'm not sure if I'm going to do a video or if I'm going to I'll probably just paste the key up on Moodle so you can check that. Let's look at the Chapter 8 handout. I want to do the front side of that today as well. And I'm going to pause. Okay, so now we're going to look at the Chapter 8 handout. So this one, what's the context? They don't really talk about it, but what can you guys assume here? I think you have enough information to start. At Montana? Airfare versus distance of what? The plane flight, right? And it looks like it says Atlanta to places. You guys see that? And then there's this like giant conspicuous blank. Do you guys see the giant conspicuous blank? That's because like there was the real data there, but I blanked it out. Why'd I do that? Maybe so, maybe so. But I think I blanked it out this time because I wanted to show you could construct a regression model without the real data. That other way that we talked about yesterday. There were a couple formulas that are very popular on AP problems, and just something to know. So let's see if I have the formulas memorized. You guys are checking me, right? So the formulas are, for the slope of a regression model, you can go the slope, which I think in your book is called B sub 1. I think it was like R, and then it was like something Y, something S, so it must have been the standard deviations, Y over X, just like Y over X for slope. Remember, I talked about how there's a math box in the book that you can look that up. I'd really recommend it, but we don't have time to do it in class. Up to you. Y-intercept for our model, besides looking at the raw data, you can go, well, first find the slope. I think it's called B0 instead of regular B for the Y-intercept. And that comes from going Y bar minus this thing, X bar.
Tamara Jessup to Student Services, please. Tamara Jessup to Student Services.
So those are the formulas for finding slope and intercept using summary statistics. Did I blank out the summary statistics for the data? No, I did not. It is there. So X bar, Y bar, SY, SX, you should have those. So you guys help me come up with those for this scatter plot thing. X bar is what? Y bar is what? SX is what? SY is what? And I think they gave you R as well. What is X bar? You guys agree with Kinsey? She says 853. Mean of the distance. Distance is X, right? Use this. Use this. She is correct. 853.7. Y bar is what? 244.3. You got it, Tyler. 3. SX is what? 497.8. That's a big standard deviation. Very spread out, in other words. SY is what? 56.37. So the spread on the Y's is less. And R, did they give us R? Oh, they said correlation, right? Remember that word correlation implies what kind of line? Oh man, I already said it. What kind of relationship?
Linear.
It's a line. Okay. So they asked us a few things here. First, they asked us to find R squared. Well, find R squared for me. I bet it's like 0.4.
481.
481? Yes. You get that by squaring r. Sounds hard. Okay, the important part though is explaining r in context. So we do that by saying 48.1% of the variation. You could say it a few different ways. Don't stray too far though. Variation in the what? What comes first? What's the thing we're really interested in if we put it this way on our graph? We're interested in learning about fares based on distance if that was our setup, right? So 48.1% of the variation in fares can be explained by our model. You can say it that way, but the better way to say it is to say can be explained by differences or variation in the x's, which is the distances of these flights. That's how you explain r squared. Yes, you need to memorize it. I don't think it's really a memory thing, it's a understanding thing, really. Number 3, I forget what it asked us. Find the slope of the regression line. How do we do that? That looks like hard algebra, I don't know. I need someone to be my calculator. And I need confirmation. Then we're supposed to find the y-intercept, so after that we're going to go what's my slope, guys?
0.0785.
Confirmation?
Yeah.
Thank you.
0.0786. Okay, thanks, Logan. And my intercept. Kinsey?
67.79.
Confirmation? 67 point something? You guys have that? No? Yeah, they say it's bigger. Or maybe a number's wrong or something. I don't think so. What are you guys getting? Book says 177.24.
Yeah.
Okay, good. 177.24. No. Wrong spot. There we go. So there's our regression model, right? We can even write the whole model now. So we can say the model. Did they ask us to do that for one of these? I bet they did.
Yeah.
Write the equation of the model. So for the equation of the model, we're going to go what? Not y hat, but
Fair hat.
fair hat. I don't think this is number 3. Fair hat equals, and you write this however you want. I'm going to say 177.24 plus 0.0786 times distance. Okay. Somebody's sleeping. Not very wise. Let's see, the next question asks you to estimate the fare for a 200-mile flight and for a 2,000-mile flight. I don't think I'm going to do that. How do I put 200 in here? Is it an X or Y? X. This should tell you. One of the reasons we write it with words is so it's really easy. So put 200 there, find your answer. Put 2,000 there, find your answer. You guys can do that. I don't think we need to do it. If they ask you to predict the distance for a fare, could you do that? Yes. Even though it's designed to go the other way, yes, you could still do that. You could plug that in and like solve for X with 2 steps, right? Like that's definitely something you could also do. So I'm not going to go over that. I think that's something we can definitely do. The next question, number 8, says use those estimates, draw the line on the scatter plot. I don't know. Yeah, the line should be like half above, half below, fit the trend. Stupid. Explain what the y-intercept means in context this time. I'm not going to write it out because I don't want to take 15 minutes to finish this side of this handout. That'd be silly. Can you guys help me orally? Explain what the y-intercept means. What's the y-intercept mean? That's this, right?
Minimum airfare price.
Minimum airfare price? That's a good idea. Montana? What do you mean? Context. A sentence. I want a sentence. If you go 0 miles from Atlanta, or wherever this is, I think it says Atlanta, right?
You're going to pay them.
Then you pay them $177.24. Does that make sense at all?
No.
If you know airport people, it might.
It might if you do it illegally.
If you showed up at the airport, they'd probably try to charge you. So it's not the way things work, though, right? So we'd say that really doesn't have a sensical explanation. Sometimes it does. Sometimes it definitely does. This time it doesn't. So explain what the slope means in context. So we'd say for each additional mile our flight has to go, you want to be complete, right? Something like that. For each additional mile our trip takes, something like that, right? We're going to have to pay how much? About 7 or 8 cents, 7.8 cents. I know you can't have 0.8s of cents, but actually, like, the people do make computations like this in business, and probably airlines, definitely. You guys ever seen Office Space? Oh man, my funny joke is just going to go away. Then you need to see Office Space. Then I can have some laughs with you.
What is Office
Office Space is a movie about like people who design a computer program that chops off these things, and they're like, oh, no one will ever notice. It's about a lot of things, but that's the main plot line. And they're like, oh, no one will ever notice, and they like upload it into their big insurance company's database, and it starts doing that, and the next day they check their bank account, and it has $3 million in it, and they're like, oh, man. Anyway, so I think in this case that 8 does matter. So, but you guys get the point. For each additional mile the flight takes from Atlanta, we're going to be paying about an additional 7 or 8 cents. Okay, next question. The fare to fly to Los Angeles, 1,700 miles, that's pretty far, is $212. Find the residual. Well, we just learned how to do that, right? So the actual price, what one is that, guys, number-wise? I want to write that one down for everybody. That was number what?
11.
11, thank you. So they said the actual fare was $1,700, or no, it was $200, wasn't it? That sounds more realistic. For how many miles? 1719 miles. They wanted the residuals. The residual in this case, E, or you could write residual, I don't care. Residual is going to be y minus y hat. So the real thing is what? And the y hat thing we're going to have to get by doing what? Oh, and I erased my model, but I've got my stuff right there. Sweet. So we're going to have to go 244 minus 0.33. No, come on. Mx plus b. Mx plus B. You don't have to do that all in one step, but there's how you do it all in one step. I need a calculator assist again. Very needy.
Can't do that in bed. Jeez. What kind of math teacher are you?
Oh, maybe I'm a bad one. Negative what?
Negative 100.5.
Negative 120.
No, negative 100, just 100.2.
100.05?
0.35.
35? Okay. That's probably just rounding differences. We use different numbers of decimals, right? Does that have units? A residual is a change in y values, so it has the same units as y values, right? So the last question that we're going to talk about today is 12 and 13 say, in general, a positive residual means what, and a negative residual, like this one, means what? What's that mean, that you get a residual of negative $100 for this flight to Los Angeles? You get $100 back?
Thing was.
Yeah. Well, this is all about predicting stuff, right? This part was a prediction. Just think about it. Here's a line. The actual value was 212. What did just this part come out to? I guess I should have asked for that. What is just this part? What is the predicted value? It's got to be... What was it? 3? Thank you, Tyler. So it's higher then, right? So here's 212. And here is the predicted value. That's your negative residual. What's that mean about negative residuals all the time?
Because it is less than what was predicted.
Yes. So how do we say that? That's good, though, Logan.
So
It's what kind of estimate?
High one.
It's an overestimate, isn't it? Here's the estimate, here's the real. So if you ever get a negative residual, that means the thing you predicted was above it. So negative residuals mean overestimates. I would really caution you against any time in mathematics or learning in general just flat memorizing something, because if you do, next month it's going to be gone. Your AP exam's not till May. That may not be the only thing that matters. I mean, if you're an AP student, I've had sophomores who took this, I think last time a bunch of sophomores did, I said like 6 of them got 5s. Austin Johnson talked to me the other day about how he was using statistics heavily in one of his pre-med classes, and he had to go back and crack open his statistics notes. Now, he had to go back and look, but as soon as he looked, he knew this stuff, right? You don't want to just memorize this short term. So don't remember, memorizing-wise, that negative residuals are overestimates, and that means positive residuals are underestimates. Think about this picture. This is what the residual meant. That should stick with you. Actual minus predicted should stick with you from a variety of classes, actually. If this is the first time you've seen it, it's just the first one. Here, actual minus predicted is positive, and that is clearly an underestimate. So don't memorize this rule. Remember how to draw the picture and look at the picture and make a decision. That's a much better way to learn anything, but especially in this, because it's easy to flip them. Does that make sense, you guys? Okay, enough didactic preachiness from me.